Hi everyone, today we discuss the graphs of two functions. The first function is y equals 2 to the power x. Let's work out some points of the graph to have some ideas about what the graph looks like. When x equals 3, 2 to the power 3 is 2 times 2 times 2. It is 8. Y equals 8. When x equals 2, 2 to the power 2 is 2 times 2. It is 4. Y equals 4. When x equals 1, 2 to the power 1 is 2. Y equals 2. When x equals 0, we need to work out 2 to the power 0. Some students have difficulty in working out the value of 2 to the power 0. If you do, I suggest you work out 2 to the power 3 first, that is 8, and 2 to the power 2, that is 4, and 2 to the power 1, that is 2, and this is the value of 2 to the power 0. Do you observe the pattern? 8 divided by 2 is 4, 4 divided by 2 is 2, 2 divided by 2 is 1, 2 to the power 0 is 1. When x equals minus 1, we need to work out 2 to the power minus 1. With similar argument. 1 divided by 2 is 1 over 2. 2 to the power minus 1 is 1 over 2. When x equals minus 2, we need to work out 2 to the power minus 2. With similar argument, we divide 1 over 2 by 2. It is 1 over 4. 2 to the power minus 2 is 1 over 4. When x equals minus 3, we need to work out 2 to the power minus 3. With similar argument, we divide 1 over 4 by 2. The result is 1 over 8. 2 to the power minus 3 is 1 over 8. When x is 3, y is 8. We have this point. When x is 2, y is 4. We have this point. When x is 1, y is 2. We have this point. When x is 0, y is 1. We have this point. When x is minus 1, y is 1 over 2. We have this point. When x is minus 2, y is 1 over 4. We have this point. When x is minus 3, y is 1 over 8. We have this point. This is the graph of y equals 2 to the power x. It is infinitely long. I just draw part of the graph. The second function I'd like to discuss is y equals 2 to the power minus x. Like the previous table, the values of x are minus 3, minus 2, minus 1, 0, 1, 2, 3. As the second function involves minus x, there is a row for minus x. Let's work out all the values in the row. The values are 3, 2, 1, 0, minus 1, minus 2, minus 3. It looks like this 3 goes there, this 2 goes there, and this 1 goes there, and this minus 1 comes here, and this minus 2 comes here, and this minus 3 comes here. What do you think about the values in this row? Will this number be 8, like this number below 3? Will this number be 4, like this number below 2? Will this number be 2, like this number below 1? Will this number be 1 like this number below 0? Will this number be 1 over 2 like this number below minus 1? Will this number be 1 over 4 like this number below minus 2? Will this number be 1 over 8 like this number below minus 3? The answer is yes. The reason is very simple. For this table, we have to work out 2 to the power x for each pair of values. We have to use the upper value to work out the lower value. And for this table, we have to work out 2 to the power minus x. And for each pair of values, we also have to use the upper value to work out the lower value. That is the reason. Therefore, we can work out the values in this row easily. Let's work out some points on the graph of the second function. Notice that when we form a point, we always use the x-coordinate and the y-coordinate to form a pair of coordinates to represent the point. When x is minus 3, y is 8. We have this point. When x is minus 2, y is 4. We have this point. When x is minus 1, y is 2. We have this point. When x is 0, y is 1. We have this point. When x is 1, y is 1 over 2. We have this point. When x is 2, y is 1 over 4. We have this point. When x is 3, y is 1 over 8. We have this point. It is the graph of y equals 2 to the power minus x. It is infinitely long. I just draw part of it. Do you notice that this graph is a reflection image of this graph in the y-axis? The reason is very simple. When we construct this graph, we first work out the row of these values. These values are symmetrical in this line. We use each of the x values and each of the y values to form a point on this graph. No wonder the point formed by minus 3 and 8 on this graph is a reflection image of the point formed by 3 and 8 on this graph. The situation is the same for the other points. This explains why the whole graph is a reflection image of the graph in the y-axis. Generally, the graph of y equals f minus x is a reflection image of the graph of y equals fx in the y-axis. Some of you may find it hard to understand f minus x. Before you understand it, you have to understand fx. What does it mean? It means an expression of x. And what does f minus x mean? It means that in this expression, whenever x appears, it has to be changed to minus x. I wish you'd find this video useful. If you do, please share the link with your friends and recommend it to others.